All right, here is a problem that I really enjoyed doing. It involves finding, or proving rather, that the area of this isosceles triangle is equal to 1/2 s squared, or 1/2 times s squared, times the sine of theta. And so let me just read it really quick. The included angle of the two sides of constant equal length s of an isosceles triangle is theta. So basically this angle right here is theta. That's theta. Show that the area of the triangle is given by 1/2 s squared times sine of theta. So how do we even begin doing this? How do we show that this is the case? And it begins by splitting up this isosceles triangle into two right triangles. So basically we will split it down like this. So I'll start by doing 1/2 over here and 1/2 over there. Here's one right triangle. And here is the other right triangle. Not perfect, but it's fine. And these lengths don't change from that split, but the angle theta does. So this will be a new angle. We'll call it, I don't know, what's another Greek? We'll call it gamma. Gamma. And gamma is 1/2 times theta. Right, we need to establish that. Okay, so what do we do from here? Well, another formula that you should know for area of triangles, in the context of triangles, is 1/2 base times height. That is the area of a right triangle. So I'll actually write that down right here. Area is 1/2 base times height. There's actually, what we are supposed to do is we're supposed to rewrite base and rewrite height in terms of trig, like a product between the height and a trig function. Let me actually just write it. So the base of this triangle is this, and we can use the sine of gamma is equal to the base, which I'll call b for base, over s, and s times the sine of gamma is the base. And we can do the same thing for the height. We just use cosine now. So the cosine of gamma is equal to the adjacent side times the hypotenuse. We'll call the adjacent side h for height. Or we could have just said a, but forget it, I'll use h. Over s. Okay. And then we just isolate h, which is just h times the cosine of gamma is, sorry, not h, jeez, what is wrong with me? Is h. So it's these two guys right here that are important, right? 1/2 times this and this, right, base times height, is the area of this triangle. And of course the same thing can be done for that triangle. So all in all, we have something like this. Let me actually erase this really quick. All in all, we have the area of this triangle is 1/2 s sine gamma s cosine gamma And of course, we have to add that to the other triangle to find the area of this bigger triangle. So we'll say plus 1/2 S sine gamma. So the same thing happens to the other triangle. S cosine gamma. And from here, you just add them, right? It would be two of these, so you would cancel out the 1/2s, right? Because it would be 2. Man, explaining stuff is hard. I don't know why this is difficult to explain. I'm trying to put words to the thought. I don't know why my mind just went blank, but so the here's what this is probably not I don't know if this is efficient. I don't care. I'm just going to include this. I'm not going to edit this out. This is what I think when I see this, because it's a big mess, right? Oh, it looks like a big jumble of a bunch of stuff, but really this is the same product. So what I think about is if I use a dummy variable like a, right, 1/2 times a plus 1/2 times a, well, that's just 2 1/2 times a, and then the 2's cancel and you're just left with a. So that's what I think about when I see this kind of stuff. So you're just left with S sine gamma times S cosine gamma. So basically the 1/2 goes away. So you're left with S sine gamma, S cosine gamma. We can actually say S squared sine gamma cosine gamma. Here's where we use our definition of gamma. Remember that gamma is 1/2 times theta. So we can write this as S squared sine 1/2 of theta times the cosine of 1/2 of theta. And then here is where I use a trig identity. What is that trig identity? I have a Toblerone bar. That trig identity is in the front of my book. It is, let me erase the board. Man, I need a bigger board. Okay. Alrighty, so let me rewrite with the last line. I had S squared, jeez. I had S squared, oh my lord. Okay, forget you saw that. I had S squared sine of gamma times the cosine of gamma, right? And then I said gamma is 1/2 times theta, so S squared sine 1/2 times theta times the cosine of 1/2 times theta. We can use a trig identity called, or within the category of product to sum formula, right? It's underneath that header. And it's basically an identity involving the product between a sine function and a cosine function. And when you use that, I'll display it actually here. And when you use that function, sorry, not function, that identity, you get this. S squared times 1/2 times the sine of the sum of these two inputs. So 1/2 times theta plus 1/2 times theta is basically theta, right? Plus the sine of the difference, right? 1/2 times theta minus 1/2 times theta is 0. So sine of 0 is 0. So I'll end that there. And basically we are finished because we have 1/2 s squared sine of theta. And that's all there is to it. We have shown that this isosceles triangle, its area, a formula is 1/2 times s squared times sine of theta. This was kind of a shitty explanation, a shitty video, shitty audio, shitty whiteboard and marker. The only high quality thing is this chocolate bar or chocolate. Oh my lord, I can't even name this shape. This is like a